Good evening. Good evening. You're welcome to our lectures today. Today we'll take a look at physics. Today is what?
26.
So the topic for today is motion. Topic for today is motion. So under the topic motion, we'll take a look at the following. Put these things down. These are what we are going to cover under motion. We will cover 1. Types of motion. Number 2 is relative motion. Number 3 is causes of motion. Then number 4 we'll take a look at types of force. Number 5 we'll take a look at linear motion. Number 6, projectiles. Number 7, Newton's laws of motion. Number what?
7.
Is that what are you pressing on that phone? Is that is not distracting you? Keep that phone by the side. Focus on what you're here to do, please. Keep that phone by the side. When you're done, you can continue. You just have 1 hour here, please, okay? When you're done, you can continue with what you're doing. Alright, the next one is after Newton's law of motion. That should be number 7, right?
Yes.
Number 8, we look at motion in a circle. Then number 9, we look at simple harmonic motion. Give me that phone. Simple harmonic motion. After you collect it, I'm distracting you. Simple harmonic motion. So these are things we are going to look at under what? This topic, motion. Okay? Good. Now let's go back to motion. Definition. What is motion? If you ask the question, what is motion? What will you say? What is motion? What is motion? Let's start from there. What do you understand by the word motion? No idea. Wow. Okay. Motion is nothing but change in position of a body with time. Motion is the change in the position of a body with time. Motion is the change in position of a body with time. But what causes that motion? Something causes that motion, right? Good. Now, if you want to look at motion with respect to, if you consider motion, and also trying to consider what causes that motion, you are looking at dynamics. Okay? You are looking at what? Dynamics. If you study motion, study how a body undergoes a motion, and at the same time, study what causes that motion, you are dealing with what? Dynamics. But if your concern is only on motion and how body moves without considering what causes the motion. If you don't consider what causes the motion, you are dealing with what? Kinematics. So we have under motion, we have what? This we have dynamics. We have what? Dynamics, okay? And we have what? Kinematics. So here, look up here, you consider the motion, how a body moves, at the same time what causes the motion. But here you don't care about what causes the motion, okay? Good. Now, types of motion. Types of motion. We have four main types of motion. They are as follows. We have translational motion, translational motion, we have oscillatory motion, sometimes this oscillatory motion can also be called vibratory motion. Oscillatory of vibratory motion. We have rotational motion, and we also have random motion. We have what? Random motion. There's a motion, there's something I want you to check up. We will discuss it in our next class. I want to hear your opinion. Is there anything like spin motion? Is it like spin motion? Find out. If there's anything like assignment, next week you tell us about spin motion. Okay? Good. So let's start with this. Let's start with what? Translational motion. Translational what? Motion. So translational motion, when a body undergoes a translational motion, it just moves from one point to another in the space without what? Rotating. If I move from here now, look up. If I move from here to here, I'm undergoing what? Translational motion. Without rotation or without moving in any zigzag pattern. Am I committing? A car that starts from the beginning of the end of this road, at the gate, and moves straight down to this place, is with respect to forgetting the tire. I mean the car itself. Forget the tire. The car itself. If you look at the car is undergoing what? Translational motion. Am I communicating? So if you move from point A in this point A to this point what? B. This is a type of what? Translational motion. Although sometimes you can have translational motion and rotational what? Motion at the same time. That is when the car is moving in a straight line, the tire is moving in a what? Rotational pattern. Is translational what? Rotational. We'll look into that. Now, okay. The next one, just okay, let's look at a bee. If you know what's a bee now? A bee. Yeah. So if a bee flies from one flower to another flower, like this, is undergoing what? Rotational what? Is it rotational or translational?
From one flower.
Yeah. Is it translational?
It's translational.
Yes, good. It's translational. That's good. Okay. So, but one significant thing about this translational motion is that every part of that object of that body undergoing that translational motion moves in that direction. Is it clear? Good. Now, so that's the example of what? Translational motion. Now, let's look at the second example, oscillatory motion. I say it's called what? Oscillatory or what? Vibratory motion. It's called what? Oscillatory or what? Vibratory motion. So, what happens in oscillatory or vibratory motion. Look at what happens there. In oscillatory or vibratory motion, see what happens. When you have a body that moves to and fro, move like this, please select this one, please. 6 dots will dismiss. You can attend to your phones. Okay. So are we together? Are we together? Yeah. When a body moves in to and fro fashion, move like this, but movement is undergoing what? Oscillatory. But what matters is that it will start from a point, move like this, and still come back to that point, move like this, and still come back to that point. That body is undergoing what? Oscillatory motion. Am I correct? It go and still come back to its original position. Any direction it will move the same distance it will move from the original position and come back to that original position. So any movement it makes, it move in that direction and still come back to what? The original position. That body is undergoing what? Oscillatory what? Motion. So, and this thing is periodic. Returning regularly at the original position at a periodic, at a particular what? Period of time. So this type of motion is periodic, but after that period, it also repeats itself again. This is what we call what? Oscillatory motion. Oscillatory what? Motion. An example of oscillatory motion is in physics. You know your simple pendulum now. The pendulum bulb you tie on the rope and tie on the rotor, on the clamp of the rotor stand. On the bus head, is it the bus head or the clamp? Or just to tie it. Once you displace it like this, it will move like this and still come back to the original position, move like this, and still come to the original position. If you move like this and come back, move like this and come back, move like this and come back, it's undergoing what? Oscillatory or vibratory what? Motion. Another example is if you have a spring. You know what a spring is now. Maybe if you have this thing they used to in physics, what they used to measure weights is spring, right? Spring balance, right? If you suspend a mass on the spring balance, it will go up, go down. If you displace it, it will go down, go back to the original position, still go down again, come up. It's undergoing what? Vibratory or oscillatory what? Motion. Now, another example is this. Have you seen a tuning fork? A tuning fork. Tuning fork. That looks, it has 2 prongs. Didn't you use it in your physics practical? It has 2 prongs like this. Something like this. Didn't you use it in your physics practical?
I know about spring balance.
Okay, so tuning fork, if you get a tuning fork and do what? If you struck it with a hard object, if you struck the tuning fork with a hard object, the prong will start vibrating. Okay? That is also a type of what? Oscillatory what? Motion. Are we together? Are we together?
Yeah.
Good. So there are many examples of what? Then, a diver in a diving board. This is a diving board. If this is the cliff and this is suspended part of a diving what? Board, they will run or jump on it, bam, it will go down, right, and go up. The diver will now enter the water or the river or swimming pool, anyone. Now, this diving board, this vibration of that diving, this going down and coming up is what? Is oscillatory what? Motion. Does it make sense? So I'm giving up to, for example, now, right?
Yeah.
Good. Because this type of question, you see different examples. They give you different examples, and you choose the correct what option, and you choose the what correct option. Now, let's look at another one. Let's look at what is the next type of motion I called?
Rotational motion.
Rotational motion. So what happened from the name rotational is clear. Is clear now. Good. So, but in rotational motion, the body, all the points in the body move in circles. Okay, like this. Look up. Move in concentric circles like this. Every part of the, unlike in translational where they move like this. If for rotational they move like this. Okay, they move what like this. Anybody undergoing this type of motion is undergoing what rotational motion. There are different examples of this rotational motion. You know the planetary movements of this planet, right? Movement around the what?
Around the
Sun, right?
yes.
That movement is what? Rotational motion. Okay? So Earth rotating around its axis is a rotational motion. Earth rotating around its axis is a rotational what? Motion. You know what? Even a ball, if you string a ball like this, if you tell it's undergoing what? Rotational what? Motion. Are we together? Then I mentioned a moving vehicle, the wheel of the car moving like this is also what? Rotational what? Motion. Does it make sense?
Yeah.
Good. Even the fan, look at this fan. Rotational motion. The blade is undergoing what? Rotational what? Motion. What is the next one?
Random motion.
Random motion. In random motion, there's no particular direction. Is haphazard, is zigzag, no direction, no particular what? Direction. So when a body moves irregularly, at random, haphazardly, disorderly, without a preferred what? Direction, that body is undergoing what? Random motion. Okay? Random motion. There are many examples of random motion. Dust particles suspended in air is doing what? Like this, three of us is random motion. What other examples do you know? In fact, random motion is capped up in our Brownian motion of particles, be it solid or liquid particles. Does it make sense? Good.
So water.
Water
There is moving.
randomly, no. Water is said.
Like a sea or a river.
On is wave now. Okay. That one is wave. So these are the types of motion. The types of what? Motion. Okay. Excuse me. Okay. Now let's look at these questions. Let's look at these questions, okay? The pattern I want to use is this. Let's look up. You know, I don't want to bog with so much thing at a time. Teach, look at questions from past questions on that particular word. So that's the system I want us to go with now, okay? So that it will, but these questions you'll be answering it now, here and now, not tomorrow, not assignment, okay? So we have this question from JAM 2014. From JAM 2014, the question says, you can put it down, or do I write on the board? No need. The question says, which type of motion do the wheels of a moving car undergo? Let me put it right on board for the benefit of those watching us, okay? So this is JAM. The question says, please put motion, please, and end, okay? Look at this question. Are you done copying? Huh?
That's the option. Just copy.
Hmm?
I'm done.
Have you copied it?
Yes, I'll write the answer.
You do what?
I've copied the questions, just the answer.
No, no. Finish up, please. Finish up. This is JAM 2014. From JAM 2014.
I'm done.
And the question says, which type of motion do the wheels of a moving car undergo? Which type of motion do the wheels of a moving car undergo? A, random and translational motion. B, rotational and oscillatory motion. C, translational and rotational motion. D, vibratory and translational motion. What do you think is the answer?
Yeah. C.
C is what?
Translational and rotational motion.
Translational and rotational motion. Correct. Correct. The wheel moves like this. Rotational, right?
Yeah.
At the same time, it's moving from this point to what? And that point. Had it been, he's not moving, he's just here, doing like this, just like this fan now. Just like the blade of the fan. Had it been the way it's just one place, doing like this, it's only what? Rotational. But because it's rotating and moving from point A to point B at the same time, it's undergoing two of them. Translational and what? So the answer is what? C. Thank you for that. Right, let me write another question. This question says, the motion of smoke particles from a chimney is typical of A, oscillatory motion, B, rotational motion, C, circular motion, D, random motion. Are you done copying? Random motion. What's the answer? The motion of smoke particles from a chimney is typical of A, oscillatory motion, B, rotational motion, C, circular motion, D, random motion. What's the answer?
Oscillating motion.
No.
Random motion.
Why do you say random?
Because it goes at a particular.
Random, particular, what are you saying? Smoke particles.
Like it goes.
Even if it goes up, does it go up like this? It goes like this, now, two of us. Does it have a particular direction?
It's not having.
This is zigzag now, haphazard. So what type of motion a body moves in haphazard?
It's random motion.
Random now. Please try to know the reason behind any answer you have. That means you know the thing, okay? I explain random motion here, right? So smoke particles that from a chimney in the kitchen. You know what a chimney is now?
I don't know what the chimney is.
In the kitchen, those kitchen in the village. If you look at the top of the roof, you see one small thing that looks like house through which smoke comes out if you are cooking, right? That's the chimney now. So smoke that comes out from there, move like this. The particles move. It doesn't move in a they move in a disordered manner. So that is an example of what? Random motion. So the answer is what?
Random motion.
Random motion. The answer is B. Random motion. Excuse me. Are you done here? So let's answer here so I can complete. After answering here, I will complete this question, okay? Alright, let's look at this question. The question says, when a ball, look up, when a ball rolls on a smooth level ground, when a ball rolls on a smooth level ground, the motion of its center is A, translational, B, oscillatory, C, random, D, rotational. This question from JAM 1995. What's the answer?
It's rotational.
Rolls, rotational, good. When a ball rolls on a smooth ground, level ground, the motion of its center is rotational.
Translational. Or because of that
Rule, yes.
I knew a ball can move by mistake.
Yeah, you see rules. And also look at the type of option you are given. This one supersedes any other one there, okay? So the answer is what?
Rotational.
D, rotational. Alright, let me now complete this question. Okay. Alright, let's look at this question. The question says, which of the following types, this is JAM 1985. JAM 1985. The question says, which of the following types of motion are oscillatory? A diving board when used by a diver. 2, the motion of the balance wheel of a wristwatch. The motion of the turntable of a record player. Turntable of a record player. You know what a turntable is now? Record player rotates, okay? Good. IV, the motion of the needle of a DC ammeter into which a low AC current is passed. So the option A, B, C says A is I and I only. B is I and I. C is I and IV. D is I and V. E is I, IV and what? V. JAM 1985. So what's the answer?
There's no option V.
No what?
There is no V.
Okay, I didn't put V here. Sorry, let me check. I, which one turntable? IV. Okay, sorry, I missed. Thank you very much for the. Let me write it through. Thank you for the observation. Let me write it through. IV is actually excuse me. Come in. Okay, let me write it here. Hope you can see it, right? From here. Good. So let me write the V here because I don't think it can be seen clearly there. So V is now so IV is the motion of the center of a 10 kobo piece as it rolls down an inclined plane. V is the motion of the needle of a DC ammeter into which a low AC is passed. Okay? So what's the answer? What do you think is the answer?
I choose. Is it B?
B is what? I agree with you. I agree with you. I. The motion of the turntable of a record player.
Presentation.
So it's not B.
I don't understand the B.
Hmm?
I understand the motion of a needle of DC ammeter. What is this?
Anyway, we'll still do current electricity, but no matter what happens, the needle always go like this now. True of us.
Okay.
It will read now.
And still go back.
No, reading. Didn't you do correct
Yes,
electricity?
but no practical.
If you connect, what will happen? It will read on the distance now. It's not like this. It reads. Depending on the amount of current that passed through. Are we together? So it will read. Once connected, it will read. The needle will read now on the ammeter now. True of us.
True.
So that is not oscillatory. Okay. This one also. This one is not oscillatory now. True of us.
Yes. Yes, the answer is A.
So the answer is what?
A.
I agree with you. The answer is what?
A.
A. The answer is what? A. Alright, let's see if we can solve another question before our time elapses. Our time has even elapsed, but let's solve one more. Okay?
Okay.
Are you not writing?
Interruption.
Okay.
I'm done.
Alright, let's look at this question. The question says, the motion of the moving skein of a talking drum can be rightly described as A, translational, B, random, C, rotational, D, oscillatory, E, transitory. This is JAM 1980. This is JAM 1980. What's the answer?
D.
D is what? Why did you choose D?
Talking drums, yeah, when you hit it, it bounces and still goes.
You are dead. I like that. It's entering share. Eh? So if this thing appear in general, you do what? Scatter it, right? Good. So you hit it, to go. True of us is what? Oscillatory. So the answer is what? D. I don't know if you have any question. If you don't have, I think we'll end here for today. So, I will say thank you very much for your attention. See you next time.